In this section, this is not out of your book, so we're just going to title it Multiplying Monomials. We first have to define, though, what a monomial is. Now, since this is not out of your book, you will need to record this in your math journal or somewhere in your notes. A monomial is an algebraic expression that is either a constant, a variable, or a product of a constant and a variable. So here's what they look like. A constant is just a number, 5, 2, 1/2. A variable can just be a letter. Or a product of both could be, for example, 4x to the third or negative 5xy. You can have more than one letter. So these are examples of monomials. A monomial is just one term. It can be written as a constant, a variable, or a product of both. So the first thing I want you to do is write down 3 to the 6th power with your examples. 3 to the 6th power, you guys should know, or do know, that 3 to the 6th power can be written as 3 times itself 6 times. Now remember, whenever you write all these are all powers of 1. So really, this is 3 to the 1st power times itself 6 times. I can rewrite that. I could rewrite this as 3 times 3, and then times 3 times 3 times 3 times 3. I still have 6 3's, and I'm still going to get the same answer. But I wrote it as 3 squared times 3 to the 4th. You could also write this as 3 times 3 times 3 times 3 times 3. Group the first 5 together, and then just the last one. That would give me 3 to the 5th times 3. All of these are equivalent. But how do you get these into a power of 6? You add the exponents. 2 plus 4 is 6, 5 plus 1 is 6. So that is your key idea today, your rule. Your key idea states this for the product of powers. For all real numbers, b, and all positive integers, m and n, you can take b to the m power times b to the n power, and that is going to give you b to the m plus n. Whenever you have the same base taken to the powers, you just add the powers together. So for some examples, example 1, r to the 7th times r. r to the 7th times r, that's 7, this is a 1, your answer is r to the 8th. Example number 2, c to the 2nd times d to the 2nd. These are not the same base, therefore you cannot do anything. Your answer is just c squared, d squared. It's kind of like taking 5 times x. 5 times x is just 5x. These are not the same base, you cannot combine them together. Example number 3. a squared times a to the 4th times a. a to the 2nd, a to the 4th, a, all the same base. You just add the powers, you get a to the 7th. The next section, problems 4 through 7, you have quite a few more variables and numbers and everything else. To simplify a product of monomials, now remember once again, you're just taking one monomial times another. You have to use the commutative and associative properties of multiplication to group the constant coefficients together and like bases together. What that means is your coefficients are, for example, -3 and 7. You're going to group those together, and then you're going to multiply like bases together. Multiply the coefficients and to apply the product of powers property that you just learned to factors with the same base. So step 1, these are just coefficients. -3 times 7. You do not add those. You do not get 4. -3 times 7 is going to give you -21. And now I want you in alphabetical order, combine like bases. Well, we have a c squared and a c. The powers are 2 and 1, so that would give me c to the third. D and d to the third, that's a power of 1 and 3. That's going to give me d to the fourth. So if I multiply these two monomials together, I get negative 21, c to the third, d to the fourth. Multiply the next ones together. Negative 5 times negative 1 is positive 5. X squared times x is x to the third. Y, oh, there's no y on this side, so it's just y. And then there's no other z to the third, or z, so I just write down z to the third. The product is 5x cubed, y, z cubed. Number 6 and 7, pause the video, try them on your own, and then start the video back up. Number 6, if you did it correctly, 3 times 4 is 12. There's just an A. B times B, the biggest mistake there is. B times B, everyone puts B. There's a 1 on both of these. If you add them, you get B squared. And then C. Number 7, 3 times negative 2 is negative 6. A to the 5th times nothing gives you just A to the 5th. B to the 4th times B to the 3rd is B to the 7th. And C times C to the 8th is C to the 9th. And there's your answers for the next part. The last two problems, number 8 and 9, you are going to simplify first, then evaluate. So let's just first multiply these together. X squared times x squared gives me x to the fourth. Y times y to the third gives me y to the fourth. I now plug in my values of x and y. X is negative 3, y is negative 1. Please make sure you follow rules. When you plug them in, you got to have the negative 3 in parentheses to the fourth power times negative 1 to the fourth power. Negative 3 to the fourth power. 3 to the fourth power is 81. A negative to an even power is positive, so it's just 81. Times negative 1 to the fourth power is positive 1. And then 81 times 1, my answer is 81. Number 9. Xy to the third times x squared y to the third when x is negative 5 and y is 2. So if I simplify first, I get x to the third, y to the sixth. Now I plug in the values of x and y. X is negative 5, y is positive 2. That's my fault. So negative 5 to the third power, since it's an odd power, it's negative, 125. 2 to the sixth power is 64. And 64 times negative 125 is negative 8,000. So today's rule that you should take out from this video is that whenever you have the same base multiplied together, you will just add the powers. Same base, add the powers.